Now, let's have a look at the quantitative risk analysis process. So we already discussed qualitative risk analysis. Now we talk about the quantitative aspect of it. Process of numerically analyzing the effect of identified risks on overall project objectives. It produces quantitative risk information to support decision making in order to reduce project uncertainty. It also determines which risks warrant a response. Quantified probability of meeting project objectives. Example, we have a 90% of change of delivering project in 8 months. So you quantify the potential risk applicable to your project. It determines cost and schedule reserves. So when you quantify it, you can look at the impact it does to the cost and the schedule. It also identifies risks acquiring most attention. Perform qualitative analysis is always done in projects. It's subjective. Perform quantitative analysis may be skipped depending on the project. Example, if your project is short and if you do not have lots of risks, you might skip perform quantitative analysis in order to save effort. Now let's have a look at some of the tools and techniques for quantitative risk analysis. As we discussed earlier, interweaving is one technique. Probability distributions is a way of looking at the continuous probability distributions representing the uncertain values such as duration of scheduled activities and cost of project components. Sensitive analysis is another way. Expected monetary value, which is known as EMV analysis. Modeling and simulations. Expect distribution are some of the other techniques. Let's quickly have a look at what these tools and techniques mean in risk management. First, interweaving relies on experience and historical data to quantify the probability and impact of risks on project objectives. Information can be gathered as in 3-point estimation technique. Probability distributions. Continuous probability distributions represent the uncertainty in values such as durations of scheduled activities and cost of project component. Probability distributions. So if you look at the figure, x-axis represent time or cost, y-axis represent likelihood to happen. So if you look at the highlighted sections, they indicate the most probable points that these risks can occur. Sensitive analysis is another tool that is used to quantify the risks. It helps to determine which risks have the most potential impact on the project. One typical display of sensitivity analysis is tornado diagram. Here is an example of a tornado diagram. So in gray color, what you see is negative impact. In black color, what you see is the positive impact. So you can see for the risks that are identified in your project context, you look at the negative impact and the positive impact and you quantify them. So this is called sensitivity analysis. The other technique that is discussed is expected monetary value, EMV analysis, a statistical concept that calculates the average outcome when the future includes scenarios that may or may not happen. Expected monetary value of opportunities means positive values. Expected monetary value of threats means negative values. Expected monetary value for a project is calculated by multiplying the value of each possible outcome by its probability of occurrence and adding the products together. A common form of expected monetary value is decision trees. Example, you are evaluating whether to build a prototype in your project or not. Here is an example of a decision tree. So this is how it goes. The prototype setup cost is 100,000 USD. So if you do not set up the prototype, the cost is zero. If you set up, then you have two possibilities. One is to fail, the other one is to get through. If you fail, 10% probability and 100,000 USD impact. If you pass, no impact at all. Now in the other scenario where you do not develop a prototype, therefore no cost. Again, you have two choices, rather two possibilities, to fail or to pass. If you fail, 50% of probability and 300,000 USD impact. If you pass it, no impact. Therefore, you can make a call yourself to proceed with building the prototype or choosing not to develop the prototype. So let's have the calculation in a detailed way. So this is the scenario of prototyping. So the expected monetary value equals 100,000 plus 10% of 100,000. So total comes to 110,000. Expected monetary value if you don't prototype. 300,000 into 50% of 300,000. That is $150,000. So expected monetary value of prototyping is cheaper than not prototyping. Thus, prototyping is better decision. Modeling and simulation. Specify detailed uncertainties of the project are simulated to find their potential impact on project objectives. Done by aid of computer programs. Generally, Monte Carlo technique is used here. Provides probability of completing the project on a specific date and cost. Here's an example. What is that? The x-axis is the cost and y-axis is the probability. So if you look at the risk perspective, it will take the curve that is shown. So the mean value of the probability possible within your project is 46.67 million USD. And you see the cost against the probability. So as you increase the cost, you see a higher probability of having more risks. So this is a technique that is used to do quantitative risk analysis. Expert judgment is another widely used technique for quantitative risk analysis. Risk register updates. Probabilistic analysis of the project, possible completion dates, cost with their confidence levels. Probability of achieving cost and time objectives. Example, probability of finishing the project with 41 million USD is 12%. Prioritize list of quantified risks. Greatest threats or opportunities are identified. Trends in quantitative risk analysis results. As quantitative risk analysis is repeated due to changing probability and impacts of risks, changes to the overall risk of the project can be tracked and trends can be seen.